Hello everyone, welcome to the Bodhi Academy. In today's PYQ series, we are going to solve PYQs of Standard 12th Physics, chapter Magnetism and Matter. Coming to the first question, a bar magnet of magnetic moment M is allowed to oscillate freely in an uniform magnetic field of strength B. If the strength of the magnetic field is doubled, what will be the effect on first, time period of oscillations of the magnet, second one, torque acting on the magnet. So let's look into the time period. The formula of time period is 2 pi root of L upon NB. So if B is doubled, so we'll get the value of T dash, that is the second time period, as T upon root 2. So the total time period will decrease. And for torque, tau equal to mb sine theta. So if it is doubled, we'll get the value as 2 mb sine theta. So torque will double. Let's move on to the next question. An external torque is applied to rotate a bar magnet from parallel to perpendicular to the magnetic field. Find the change in potential energy. So potential energy U is given by mb cos theta. So initially Ui equal to minus mb cos 0. So that will be minus mb because cos 0 is 1. Finally, UF is equal to mb cos 90. Cos 90 is 0. So that will be 0. So change in potential energy is final potential energy minus initial potential energy. So that will be plus mb. What is coming to the next question? What is the effect of on a diamagnetic material when cooled to a very low temperature? Diamagnetism is independent of temperature, so there won't be any effect of temperature since it is caused by orbital electron motion. There is no effect of temperature in it, so no changes occur. Let's move on to the next question. Why does a paramagnetic sample display greater magnetization when cooled? Thermal agitation decreases on cooling, so dipoles align better with the field, increasing magnetization. Coming to the next question, what happens to a ferromagnet at a very high temperature? So above Curie's temperature, it loses ferromagnetism and it becomes paramagnetic due to randomization of dipoles. So it will lose its magnetism. Let's move on to the next question. When a magnetic needle free to rotate in a horizontal plane is taken to a magnetic pole of the earth, it cannot orient itself. Why? At the poles, horizontal component H is equal to 0. So the needle has no horizontal direction to align with. Therefore, it cannot align itself uh, when the horizontal plane is taken to the pole of the earth. Coming to the next question, a magnetic needle is free to rotate in a vertical plane, is taken to a magnetic pole. How will it orient itself? So at the pole, the field is vertical, so the needle will align vertically to the field. Coming to the next question, what do you mean by angle of dip? Angle of dip is the angle made by Earth's magnetic field with the horizontal at any point on the Earth's surface. So let's take this diagram for example. So this is Earth's magnetic south pole, this is Earth's magnetic north pole. So this angle that you see, this angle is going to be the angle of dip. Coming to the next question, how will you convert a ferromagnetic substance into a paramagnetic substance, B, a permanent magnet? So by heating the material above Curie's temperature, we can convert it into a paramagnetic substances. Curie's temperature is the temperature at which a ferromagnetic substance can be converted into paramagnetic substance. At this point, the thermal energy is too high, so it is difficult for it to align at that particular temperature. To convert it into a permanent magnet, by placing it into a strong magnetic field or stroking it with the magnet in one direction, a ferromagnetic substance can be converted into a permanent magnet. Coming to the last question, how will you identify whether a given magnetic substance is diamagnetic or paramagnetic? By placing it in an external field? Place the sample uniform field, and paramagnetic substances will get attracted towards a stronger field region, and diamagnetic will be repelled from a stronger field region. They do not get attracted by the stronger field, so they are repelled by the stronger field region. Thank you for watching today's videos. Don't forget to like, share and subscribe to the Bodhi Academy. Thank you.